Hi guys, in this example, we have a slightly different situation than the rest because this is the example here simply supported with a point load and a UDL acting on the same segment between A and B. In this case, we cannot quantify this one bending moment profile, and during the previous example, we can at least quantify one bending moment. Use that one bending moment, we can work out the reactions. But in this case here, we do need to use equilibrium equations to solve at least one reactions, and starting from there. So this start from, you can set your moment B at the 0 or A, either way, it doesn't matter. So I'll just take a moment B equals 0. I need to solve a reaction at the point A. So moment B equals 0, clockwise is positive. Write that down. That gives total length is 8 times RA, and your UDL converted to concentrated is at 2 times 4 times the central distance to the endpoint of interest as B is 6 meters, and continue minus 8 times 2 equals 0. That gives you RA equals 8 kilonewtons. So your RA is 8 kilonewtons. Now we've got one reactions. Now we can work out the bending moment diagram. So based on that, we can say at the point C here, so this point C here, you've got a point coming upwards, that's 8 kilonewtons, your lever arm is 4. But also you've coming down 2 kilonewtons meters UDL at the length of 4. So imagine there's two forces that is cancelling each other a portion of it. Therefore, at the cantilevered moment is PL over, just simply PL is going to be 8 times 4 gives 32. So I'm gonna draw just a dash line through it. I'm just say here it's gonna, okay, this is gonna be 32. However, there's a portion of the load that is cancelling that uplifting, that is coming down 2 kilonewtons meters times 4. That lever arm is going to be, because you have to consider it as a cantilevered. So that moment cancelling each other is going to be omega squared over 2. That's 2 times 4 squared over 2. That is 16. So you have a counterbalanced 16 kilonewtons from 32. So that lowest point here is 16. Now it is pretty sure this point here is going to be 16. Now I can connect 16 to point B because I know this is 0. At the point, that's point D here, from the trigonometry, this point here is going to be 8. Using triangle, this point is going to be 8. And from there's another 8 kilonewtons point load here, so that is going to be a triangle upside down, something like that, just connecting together. So this portion here, this vector here, is just the PL over 4. That is 8 times 4 divided by 4 equals 8. So there's extra 8 kilonewton meters stacking up 8. So here is 16. Coincidence. So this should be a straight line. Moment here, straight line, and then connecting to the point B. So here we go. This is the bending moment diagram for the simply supported. And now we can work out reactions, because this is 16 divided by 2. The slope here, 16 divided by 2 is 8. So we can coming up, the total load is 8 plus 8 is 16. And you can work out the total 2 times 4 plus 8. And that is to 16 as well. Yep, correct. Okay, this is how you quickly work out your bending moment diagrams. And this case, as I said, is slightly different because you don't know, you're not sure how to quantify at least the one bending moment. But in this case, at least you can sort out one reaction first and use the reaction to sort out the rest of it. Yeah, so if you have any questions, just make a comment below. Otherwise, I will see you in next episode. Thanks.